Welcome back. This video is actually the fourth in a series of Git videos that I'm making for this channel. If you haven't already seen the previous three, I'd recommend checking those out beforehand in order to fully understand the topic that we're going to cover in today's video. Enjoy.
Git!
The problem is now every time I film one of these videos I have to figure out the next step in the madness to yelling out Git. It's quite a corner I've painted myself into. This is another video for the Git mini-series that I'm creating for my channel in order to help you fully understand Git and how to properly use it. In the previous three videos we covered the immediate basics of what is Git, Git Add and Git Commit. Then we went into one of the massive parts of Git, which is branching. And finally, in the previous video, which was incredibly long, I'm so sorry about that, we covered the often tricky part of merging. Hopefully I explained it in such a way that it wasn't so tricky. Everything that we've done up until now has been solely on our local machines. So we've had no interaction with any sort of cloud or repository in the sky. Everything we've done has just been on our machines locally. However, most of the time in any sort of team you work with, you'll probably be using Git with some sort of cloud or a server of Git, a central repository if you like, somewhere that once you've made changes to the code on your machine, somewhere that you can put that code, either to keep it safe or for somebody else to see. In this video, I want to show you how you take your local work, all of the commits and branches and stuff that you've been making on your machine, and connect it with a remote repository. Ladies and gentlemen, in this video, I want to talk about remotes and pushing. Let's do this. Hi there folks, my name is Ben and welcome back to the channel. As usual, if you enjoy what I do on this channel, then please consider hitting that subscribe button. And if you like this video and the Git mini-series that I'm doing, hit that thumbs up button to let me know. One of the main reasons that we actually use this Git software is not just to annoy us as developers, to have this sort of tracking tool to keep a history in case we make a mistake and go back to it, but instead it's because of the power and ability that it has to enable us to have multiple people working on one project together. Imagine, if you will, a world without version control software. How does a team of maybe 5, 6 to 10, maybe even 20 developers work on a piece of code together? Maybe they have a USB stick and they write the code on there and pass it around physically. Maybe they have a networked drive that they work on, and then when they're working on it, they have to yell and tell the others not to touch it whilst they're changing it in case they break it or do something wrong to it. So Git enables multiple people to work on one project by providing remote repositories. Then developers with their own machine connect up to that repository, take a copy of the code as it is in that situation, change it, and then put their changes back onto that remote repository. They push their changes back into that remote repository. 99% of the time there will just be one remote repository. It'll be like a single server somewhere that every developer connects to, and that's like their one source of truth, if you like. However, it doesn't have to just be one remote repository. If I show you on my screen really quickly, hopefully you remember this image from the first Git video that I made for this series. So far in the previous three videos, we've just covered things that are within your local machine. We haven't even looked outside of this machine yet. Yeah, we did a sort of a clone right at the beginning, but so far we've just worked with the three areas, and hopefully you remember that awful kids in the kitchen making cookies analogy that I made. We're going to come back to that later. Now I want to bring your attention to the thing in the top middle, the remote repository, this cloud that has a picture of like a database or a repository in the sky. Developers interact with it by, cloning it down or fetching and pulling, we'll talk about in another video, doing their changes, committing, and then pushing their changes up to the remote repository. And that's what we're going to talk about in this video today. Hopefully you remember this picture from the first video. The gray box up here with my stupid face on a lady receiving a basket of cookies is the bit in question in this video. This is the remote Git repository. Now we're going to be looking at this command, this Git Push command, to take what you've put under the tree, the nice commits in the cookie baskets that you've made for mum, and give them to her. Essentially, in the analogy, your mum is the remote Git repository. I always feel that the stupider the analogy, the better that I remember it. So hopefully it's the same for you. As we had commands like Git Add to add things to the cookie basket and Git Commit to store things, the sort of save in Git to put things under the tree, we have this other command called Git Push, where you take that branch full of commits maybe and push it up to the server. Push it, you can use the push analogy if you like to see me in your mind pushing into the corner of the screen. That can be sort of translated into upload my changes please. So there's a bit of the theory. Let's head back to our repository that we were working with. I'm inside that folder now, the Git series folder. I'll do a Git log to just show you that there's commits in there. In fact, I'm going to use a command git log -- one line, which lets you see all of the logs and gives them each one line. There's a little tidbit for you. So you can see there's, I don't know, what is that, 10, 9, 8 commits there, starting from the bottom, going up to the newest one. If I do git branch, just to remind you that we have a master branch that we're currently on with the asterisks, and we made 2 new branches with feature and conf, and we did some stuff with merging. At this moment in time, if you followed along with the video, our repository doesn't have any sort of knowledge of any server or any remote anywhere. We started it with a Git in it, we started it from scratch, and we just changed some code and we did everything on the local machine. The first thing we need to do is, well, have a remote repository available for it to connect to, and then tell our repository about the remote. A remote Git repository is just a server somewhere else that has our Git repository. Most of the time you won't just set up your own Git bare repository. I'll probably cover bare repositories in another video. Most of the time, in fact, you will use a third-party provider to host your remote Git repository. There are many, many different options to this. The most well-known options are GitHub, Bitbucket, GitLab. I think SourceForge is still a thing. Anyway, there's lots of different options, and the majority of them are completely free. So what I need to do is pick one of those third-party providers, and in this case, I'm going to pick GitHub, and I need to set up the remote repository, ready to connect with my repository. So I've logged into GitHub, and I'm going to go to the top right corner, the little plus icon, and new repository is the option I'm going to pick. This is going to set up a new repository for me. Here I need to just give it some bare details. I'm going to give the repository a name, and it really doesn't matter what the name is at the moment, so I'm going to just do Git series. I can give it description optional. I'm just going to put YouTube Git series, y'all. Cool. You can set it to public or private. If it's private, only you, the user who has created it, can see and access and change things. If it's public, then other people can see and access and change things. However, asterisks, these third-party provider websites like GitHub and Bitbucket, they do online collaboration in a slightly different way to each other, and I'll cover that in another video. For those of you who are confused with what I'm saying, I'm talking about GitHub needing to have forks of the repository, and Bitbucket, you need to sort of have permissions to join onto that repository. But don't worry about that, we'll cover that in another video. For now, I'm just going to set up a public repository so that everyone can see the code, and I'm not going to initialize it with a README file. README files are traditionally just files that explain what the repository is to somebody that's just stumbling upon it for the first time. And I'm not going to add a git ignore or a license, and I'll cover those in another video. For now, I'm going to hit create repository. So that's done. It's created the git_series repository for me. Right now, there's nothing in it. You can see these tabs, it says code here. There's no actual code in it. There's more sort of instructions to set up my repository. There's instructions if this is a sort of brand new repository that I want to create alongside this remote. And you can see some of the commands like git init and git add and git commit like that we did. Or there's instructions on how to connect it to an existing repository. This is the route we're going to take. We have an existing repository and we just want to give it a server. We want to give it a remote Git repository to connect to. So in the case of GitHub, it's given me the actual lines of code that I need to type in to make this connection happen. But I'm going to go through these one by one and explain what they're doing. Okay, to start with, I'm going to copy this first line, Git Remote Add Origin, and then a URL, which is the URL actually to this online repository. Okay, but we'll talk about that in a second. I'm going to copy that, and what I can do is I can paste it straight into there and just hit enter and it'll be fine, but I'm going to paste it in and I'm going to explain what's going on. So Git Remote, let me just get rid of this. Git Remote is another Git command. And if I just do git remote by itself, it will list out to me all of the remotes that I have. And currently it's not listing anything because I haven't assigned a remote to it. When I say remote, you can just translate that to mean like server, Git remote repository, a Git server somewhere. A repository can have more than one remote. The next bit, Git Remote Add, is a sort of subcommand of the remote command. So it's going to say, hey, I want to add a remote. And right now that won't do anything if I hit enter. And the next two bits together are the final piece of the puzzle, the word origin and then the URL. Okay, I'm going to space and enter and paste those in. So the origin is just a nickname that Git gives to your server so that you do not have to type in this awfully long, stupid URL every single time. What you're doing here is saying git remote add and then this long URL, but with the nickname origin. And it doesn't have to be origin, that's just sort of traditional. It could be whatever you want. It could be something like that, right? It's a bit annoying to do that. Don't do that though. Just do origin for now. So the nickname and then the actual URL of that remote repository. And as I showed you before, that URL, github.com/leo git series, matches the exact URL of the online repository that you just made through GitHub. So git remote add origin and the URL will now connect up my local machine. It'll say, hey, local Git repository, I just want to tell you about this remote repository that exists, okay? It's not doing anything else, it's just saying, hey, this exists with this URL and we're going to nickname it origin for shorthand purposes. I'm going to hit enter. Nothing has happened, like there's no output there. It has just happened behind the scenes. It has connected the URL git_series.git with the nickname origin in my remote. So if I now do git remote, you will see that there is one remote called origin. The nickname is origin. And if I just do git remote with the -v flag for verbose, it's going to show me the URL attached to origin. And there's one URL for fetch and one URL for push. We're going to cover those in a separate video. Okay, but currently they're the same URL. So basically what this is saying is it's getting and giving the information and getting the information from the exact same URL. Okay, back to GitHub. The second command and the final command, I guess, is this git push origin master. Means nonsense, nothing, but I'm going to explain it and break it down for you now. As with git add, git commit, git log, git status, git push is just another git command. And what push does is, as I told you before in the analogy, it pushes, it uploads something to somewhere. So git push, it's pushing the commits, it's pushing the branches with the commits in somewhere, okay? For now, I'm gonna skip this -u bit and I'll tell you about that in just a second. And I'm just gonna say git push origin. Now, for those of you who are keeping along with me, origin is just the nickname of the server. So wherever you see origin, you can pretty much translate it in your heads to just be that URL. So git push to the URL, or to origin, so our remote that is called origin, git push to origin what? What are we pushing? Well, that's nice and easy. Master. A branch name at the end of that. So git push to, in this case, GitHub, master, the master branch, the current state of the master branch. If I did that now, that would work. And in fact, I'm going to show you that working right now. I'm going to hit enter. We're going to wait for a little second and see what happens. So it does some stuff about counting objects, resolving deltas, resolving differences, and you can even see the URL it's pushed to. And what it's telling us is it's created a new branch on the remote repository, okay? It's created a new branch on the remote repository called master, and it got it from master, right? And it did some data transferring, compressing objects, writing objects. Basically, long story short, it shoved all of our master branch online to origin. And origin, of course, is this URL. So let's go see. If I go back to GitHub now and I refresh this page, let's watch. I've refreshed it. You can see now the instructions have gone. It now has some stuff in it, some code, some files. Of course, our project was just like nonsense text files, wasn't it? So if I can click onto the abc.txt file and see this is an old file. I can go to notes.txt and see all of those stupid lines of code that we added. That has been a push to that repository. Let's talk a little bit more about that push command. And in fact, let's just go back to try and understand what that -u argument was. So it was, the full command was git push -u origin master. That's before I'd done anything, okay? The -u option is set an upstream tracking branch. Okay, that is completely confusing right now. And in fact, I don't want to go too deeply into tracking branches in this video. That's going to be in a future video very soon, hopefully. However, what I do want to tell you is if you put that -u option, then every time that you do the git push command in the future on the master branch in particular, you don't need to do the full git push command like this, okay? Because you've done that -u option to set this upstream tracking branch, which we'll cover in the video, you can just do the git push command like this with git push, and it knows what you want to push and where you want to push it, because you're inside of a branch, of course, and it knows already what that upstream tracking branch is, okay? And again, I'm going to cover those in a future video, but just know that -u is quite helpful. However, the traditional git push command will always be git push where you want to put it to and what you want to push, okay? So the where is the remote name, so origin, 99% of the time it'll be origin, unless you have more than one remotes, okay? So you could add more remotes to your repository. You could just tell your repository, hey, there's this server there, Git Remote Add, there's this server there, Git Remote Add, there's that one there, and then you'll have a bunch of remotes, and of course they'll have different nicknames. So you could do git, imagine if I had a remote called hat, I'm rubbish off the top of my head, I have another remote called git hat, I would do git push hat, and then the name of the branch, so master in this case. Remember, I have other branches and I might want to push those too. So let's push the feature branch. I don't actually need to be in a branch to push it if I don't want to be. I could push that feature branch just from here. So let's do that. Git push origin, because I'm pushing it to my GitHub server. And then the name of the branch I want to push, feature. Git push origin feature, I'm going to push that branch. Cool, so it's done some figuring out, and this is what's happened. The remote has sent some messages back to us. We can create a pull request for feature, okay? I'm going to talk about pull requests in another video. I just want to keep this video as concise as possible. I know it's gone on too long already, but it has also done what the git push origin master did, and it created a new branch on the remote called feature from feature. And again, if we go back to GitHub, you can see here currently one branch before I hit refresh, and now it has two branches, and if I click on that, you can see master and feature, active branches, your branches, default branches, yeah. If I go to the Git series, the main tab in GitHub, and it's not a GitHub lesson this, but you can see the branch here, and you can change between the branch you're looking at there. Now we've done our first git push, let me make some changes to our code base, commit it, and then push those commits on top so you can see the update, okay? So right now, in the master branch, in the abc.txt file, we have, this is an old file. I'm going to make a change and upload it, okay? So I'm going to go into the ABC file, and I'm going to just add a line saying, here is a new push line, okay? I'm going to save that file, close it, let's just look at it. It's got two lines in it, the first line and then the new push line. Okay, I'm going to do our old commands, git status, to see that something's changed. I'm going to do git add dot to add everything, and then just do git status again. We're going through the process. Something's been modified. It's been added to the staging area, if you can remember back long ago to the other videos. And now I'm going to do the glorious command of git commit with a message in one line, just saying I added a line. Hooray! Okay, something like that. Awful. Git commit. So I'm going to do the commit, and it has committed. Let's clear the screen. Let's do git log --one line to see that the top commit is the one that says I added a line. Hooray! Okay, I'm going to clear the screen, and now I'm going to just quickly go back to GitHub and show you that that's the ABC file currently as it was online. I'm going to do git push origin master again. Okay, hit enter. And it's going to now take my version of master and push it again onto the repository. So nothing different, it's just going to push it. The message is different this time, okay? It didn't create a new branch because master already existed on the remote. Instead, it has fast forwarded master. And this is one of the best parts about the git push command. It has a safety net built into it. Git push will only successfully push your code if it's performing a fast forward on that remote branch. Do you remember fast forwards from the merge video, where it's just your sort of branch catching up? It's like there's nothing new, nothing's diverged, it's just catching up with commits it's missed. Git push will only succeed if it's performing on the remote repository side a fast forward, okay, if it's going new. It will not work if, for example, your remote repository's version of master has changed somewhat, and then you're trying to push your version of master. It will go, no, it's not a fast forward, there's like conflicts, it's having to deal with merging there. It will say no to the Git push, which is great because there's a safety net built into it. However, with all things to do with Git, it's all about the control that it gives you. So you can override this feature, which is not advised. I do not recommend you do this, but you can do Git Push Origin master or Git push, whatever your command is, -- force, okay? And that will override that safety net. It will say, nope, no, I know what I'm doing. Take my version of master, and it will simply overwrite the remote repository's version with your version. It's dangerous. I do not recommend it. Stay away from that completely if you can. The way to get around doing a force push is by fetching and pulling. These are two commands that we'll talk about in a future video, but fetching and pulling, updating your machine's version of the remote repository, and then merging in those changes to your branch and then re-pushing it, okay? So it's a bit of an effort, but it is advised and recommended. And we'll show that in another video when we talk about fetching and pulling. Okay, so I pushed up the updated version of the master branch, and I'm gonna go back to the Git series online repository in GitHub. And you can see already, if you paid attention, there's now 11 commits here, and there's this I added a line hooray message that we made in the last thing. And what I'm going to do is I'm going to click into the ABC text. I'm inside of the master branch. I'm going to click into the ABC text and see that it now has 2 lines. So when you're doing the Git push, if that branch already exists in the remote repository and it can update it, it'll just update it. If the branch doesn't exist, it will add the branch. Here's another useful little tip. If you do Git Push Origin or whatever server you want it to push it to, -- all, it will push all of your branches. Let's see that happening now. I'm going to do Git Push Origin -- all, and hopefully it'll see that there's the master's no different. It'll see that the feature branch is no different, but that third branch, the conf branch, which we also had here, it's now pushed that as well, so new branch. It's just a quick way to update all of your branches to the server, so do a big full upload sync. Okay, so that was it. That's all I wanted to cover. The Git push command, and of course you saw the Git remote command as well. There's a couple of things that I just want to point out that I'm definitely going to cover in future videos, and hopefully they'll be released soon. First of all, that Git fetching and pulling, which is like asking the server, hey, have you got any changes? Give me those changes from other people. We're going to cover that in a future video, I promise, because that'll hopefully clear the puzzle up. And of course, I want to talk about remote tracking branches, or these upstream tracking branches. In a future video, of course, I'll talk about the differences between GitHub and Bitbucket and maybe GitLab, or some of the online third-party providers for these remote Git repositories, these basically websites that let you host your online Git repository. I hope you enjoyed this video, and I hope it made sense, and I hope it sort of demystified the very, very first part of the online remote repository part of Git. This has just been the top layer of the Git remote experience, if you like. Thank you so much for watching. I hope you enjoyed the video. If you did, please give it a like. And of course, if you haven't already subscribed to the channel, please do so. Chop chop. Ooh, make sure as well you hit that bell icon to be notified when I release future videos, so that you can see the future videos of this Git mini-series that I'm creating. Thank you so much for watching. See you next time. Yeah. Intro card. That was 8 minutes. F off, was that 8 minutes? Shit. Bit of hitting that subscribe. Give me that tea. Oh. I'm an idiot. Imagine, if you will, that a branch not on that screen, you swap displays, you limey piece of shit. Okay. I'll just do it with my words. I'll just use my words. That was a great shoot. That was good. I'm getting better at this.